What if the future of water isn't in some futuristic machine, but buried in the ruins of a 2,000-year-old desert civilization? Because right now, our modern technology is struggling to stop a global water crisis. Governments are spending billions on desalination plants, pipelines, and energy-hungry infrastructure. And yet, entire inland regions are still running dry. But long before electric pumps or satellites, one ancient civilization figured out how to do something that still seems almost impossible. They made the desert hold water. Not for days, for generations. Hidden in the carved sandstone canyons of Petra, the Nabataeans built a water system so advanced that some researchers believe its core principles could still outperform parts of our modern drought infrastructure today. And once you see how they did it, the real question isn't whether ancient people were smarter than we think. It's why we stopped building like them. We tend to think the solution to water scarcity is more technology. Bigger plants, longer pipelines, more energy, more complexity. But the global drought crisis is exposing a major weakness in that logic. Modern desalination can create enormous amounts of fresh water, but it comes with huge costs. Massive energy demand, expensive infrastructure, and ecological side effects. And there's one critical limitation most people never think about. Desalination usually helps coastal zones first, but drought does not stay on the coast. The places facing the worst water stress are often inland, remote, or too poor to support giant centralized systems. This means even when we can make water, getting it to the people who need it most becomes a second crisis. And the farther that water has to travel, the more expensive and fragile the whole system becomes. In other words, modern water infrastructure often depends on constant industrial force. Pump it, move it, treat it, repeat. In an age of intensifying heat and rising energy costs, that model starts to look less like a solution and more like a trap. Which is what makes Petra so fascinating. Because the Nabataeans solved the same problem from the opposite direction. They didn't force water across the desert. They taught the desert to catch it. The Nabataeans were an ancient Arab civilization whose kingdom flourished in one of the harshest environments imaginable. And yet, somehow, they turned Petra into a thriving urban center in a landscape that should have made large-scale settlement nearly impossible. That alone is extraordinary. But the real marvel wasn't just the city. It was the hidden hydraulic intelligence running underneath it. The Nabataeans understood something simple but profound. In arid climates, survival doesn't depend on finding giant rivers. It depends on mastering rare water events. Flash floods, seasonal runoff, short bursts of rainfall. They saw tiny gradients in terrain, the shape of rock faces, the speed of moving water, and the danger of losing it all in a single storm. Where others saw a hostile desert, they saw a giant water harvesting machine. This is where the story gets incredible. The Nabataeans built networks of channels carved directly into stone, designed to intercept and redirect runoff before it disappeared into the desert floor. They created terraced landscapes that slowed water down, reduced erosion, and increased infiltration. They cut cisterns into rock, storing precious water underground, where it was protected from heat and evaporation. And instead of relying on brute force transport, they used gravity. No pumps, no electricity, just precise engineering and deep environmental knowledge. Every slope mattered. Every storm mattered. Every drop mattered. The genius of the system wasn't just storage. It was control. Too much speed, and runoff becomes destruction. Too little capture, and rainfall vanishes. The Nabataeans built for all of it. They anticipated a flood, then slowed it, redirected it, filtered it, and stored it. Which means Petra wasn't surviving despite the desert. It was surviving by decoding it. Now, to be clear, ancient cisterns are not going to replace every modern water system on Earth. They are not a magic substitute for treatment plants or urban-scale supply grids. But that's not the point. The point is that in arid and drought-prone regions, especially inland communities, the Nabataean approach solves a problem modern systems often handle badly: how to create resilient, decentralized, low-energy water security close to where rainfall actually lands. Modern systems are often centralized. The Nabataean model was distributed. Modern systems depend on constant energy input. The Nabataean model used terrain and gravity. Modern systems often react after scarcity begins. The Nabataean model was built around harvesting brief abundance before it vanished. And that changes everything. Because resilience isn't just about how much water you can produce. It's about whether your system can keep functioning when energy prices spike or infrastructure fails. And in that category, ancient design starts to look surprisingly modern. The most important lesson from Petra might not be the structures themselves. It's the philosophy behind them. Modern engineering often tries to overpower nature. The Nabataeans engineered with it. They studied slope, stone, runoff, and evaporation, then built systems that cooperated with those realities instead of fighting them. That is exactly the kind of thinking climate adaptation now demands. The future is not just about inventing bigger machines. It's about designing systems that are local, passive, repairable, and resilient under pressure. In many droughted regions today, that could mean subterranean cisterns inspired by Petra, terraced runoff capture systems, and gravity-fed conveyors. Not as museum pieces, as infrastructure. The terrifying thing about the global water crisis is that it is easy to imagine technology eventually solving it somewhere. The harder question is whether those solutions can arrive fast enough, cheaply enough, and locally enough for everyone. That is where ancient systems become more than historical curiosities. They become design evidence. Proof that humans have already built thriving water systems under extreme desert constraints. Proof that resilience does not always require high energy. And proof that old knowledge can become future infrastructure. Maybe that's the real story here. Not that the Nabataeans were ahead of their time, but that we may have built a modern world so obsessed with scale and power that we forgot one of the most efficient survival systems ever carved into stone. If the water crisis defines our future, then solving it may require more than new inventions. It may require recovering old intelligence, because hidden in Petra's cliffs is a reminder that the best technology is not always the newest. Sometimes, the best technology is the one that already proved it could keep a civilization alive in the desert. And if a lost city could do that 2,000 years ago, what exactly is stopping us now?